Okay, let's dive in. Imagine something really fundamental in medicine, something happening millions of times a day, all over the world.
Like starting an IV.
Exactly. Hooking someone up to fluids sounds completely basic, right? But here's the thing. For over a century, there's been this really intense debate about which simple saltwater solution is actually the best one to use.
It's wild when you think about it. It's such a common thing.
It really is. And the story behind it involves, believe it or not, frog hearts, battlefield medicine, some pretty dramatic scientific U-turns, and even huge clinical trials getting interrupted by a global pandemic.
It's a fantastic example, really, of how even the most basic medical practices evolve. It's often slow, sometimes messy, but driven by, observation, new ideas, and constant testing.
Totally. And today we're going deep into that whole saga. We're using the sources you've shared, historical accounts, key research papers, right up to a brand new study, actually published today, June 12th, 2025.
Yeah, hot off the press.
Our mission here is to help you understand why this choice, this seemingly simple fluid choice, has been such a big deal for so long. Let's trace this amazing story.
Okay. And like a lot of science stories, it kicks off with, well, kind of an accident. Picture Victorian England, gaslit labs, the 1880s. There's this British physiologist, Sidney Ringer.
Right, at University College London, and he's studying something very specific, isn't he? Frog hearts.
Isolated frog hearts, yeah. He was trying to figure out how they worked, how they contracted. So his goal was to keep them beating outside the body.
In vitro, basically,
Right.
in the lab, perfusing them, right, flushing fluid through them to sort of mimic the body.
Exactly. And his standard go-to fluid for this was just simple saline, salt and water. He figured that should keep the cells, reasonably happy.
But then came the twist, the accidental part.
The accidental part. His lab assistant apparently mixed up a batch. Instead of using pure distilled water like he was supposed to,
He used tap water.
he grabbed water straight from the tap, specifically from the local supplier, the New River Water Company. A mistake.
Wow. Okay.
But Ringer, being the careful scientist he was, he noticed something weird. The hearts he was perfusing with his standard pure saline, they'd weaken pretty quickly, stop beating.
Right. As you might expect, maybe.
But the hearts getting the saline mixed with the tap water, they get beating strongly, vigorously, for way longer.
That must have been confusing. Why would, regular London tap water be better than his pure solution?
Exactly. And this is where Ringer's brilliance comes in. He didn't just ignore it. He dug in, systematically tried to figure out why. He started adding tiny amounts of different things he thought might be in the tap water to his pure saline.
Like what?
Potassium, bicarbonate. Nothing quite did it. Until he added calcium.
Ah, calcium.
He found out the New River water had these trace amounts of calcium salts. And the magic formula wasn't just sodium chloride, the salt. It needed potassium chloride and calcium chloride too, and crucially in very specific proportions.
So plain saline just wasn't cutting it. The cells needed this precise mix, this electrolyte cocktail, sodium, potassium, and calcium.
Precisely. It wasn't just about the overall concentration, the tonicity, which affects water movement in cells. It was about having the right ions present in the right balance.
Okay. So he nailed down the basic recipe for a fluid that living tissues could actually thrive in.
Yep, that was Ringer's solution. A fundamental discovery born from a mistake and really careful observation.
Okay, so Ringer lays the foundation. Let's jump forward, half a century? Now we're in the 1930s, America. And doctors have a different crisis.
Severe acidosis. Really dangerous buildup of acid in the body. They were seeing it a lot in children, especially those severely dehydrated from things like cholera or bad gastroenteritis.
And tackling this head-on was an American pediatrician, Alexis Hartmann.
Right. These kids weren't just lacking water. Their whole body chemistry was off, dangerously acidic. They needed something to counteract that acid, to buffer it, restore the pH balance.
Were there options?
Well, they had bicarbonate solutions, but they were problematic. Kind of hard to sterilize properly. They could irritate the veins. And maybe worst of all, if you gave them too fast, you could easily overshoot.
Causing alkalosis instead. Trading one problem for another.
Exactly. It was a real tightrope walk. Hartmann needed something safer, more controllable.
And he had an idea.
The really clever one. He looked at sodium lactate. He realized the body could use lactate as a kind of precursor to bicarbonate.
Ah, so instead of dumping bicarbonate in directly, you give the body something it can convert itself.
Precisely. He took Ringer's solution, that balanced electrolyte base, and he added sodium lactate to it. The genius was that the liver metabolizes lactate, but it does it gradually.
Okay.
So it produces bicarbonate slowly, more physiologically. It helps the body correct the pH imbalance using its own machinery, avoiding those sudden dangerous swings.
So clever. You take Ringer's electrolyte balance and add this metabolic buffer.
And that modified solution, Ringer's plus lactate, became Lactated Ringer's solution, or as it's often called, Hartmann's solution.
A huge improvement, especially for those really sick, acidotic kids.
Oh, absolutely. It became a standard.
Okay, let's switch gears again. Different time, different continent, different kind of crisis. Vietnam War era. 1960s, 70s.
Yeah, the battlefield. Doctors are dealing with horrific trauma, massive blood loss hemorrhage on an unprecedented scale.
Right.
Resuscitation was absolutely critical.
And there's a key figure here too, right? G. Tom Shires.
G. Tom Shires. His work really revolutionized how we think about fluid loss and severe shock, especially trauma shock. Before him, the thinking was pretty simple.
Lose blood, give blood.
Basically, yeah, just replace the volume loss from the blood vessels. It seems logical.
But Shires found it wasn't the whole story.
Not even close. His research showed that in severe shock, yes, you lose blood volume from the vessels in the intravascular space. But there's also this huge shift of fluid out of the blood vessels to the surrounding tissues, into what he famously called the third space. Basically, fluid pooling in injured areas, in swollen tissues, places where it wasn't doing any good for circulation or oxygen delivery.
So the fluid is still in the body, but it's functionally lost.
Exactly. Shires proved that just giving blood back wasn't enough. You had to account for this massive loss of fluid from the entire extracellular space, not just the blood vessels.
So you needed something more than blood.
You need crystalloids to refill that whole extracellular space. And the fluid they used, lactated ringers. Shires' work, proven under the toughest conditions in Vietnam, showed that giving LR aggressively, alongside blood, was essential for restoring fluid balance and dramatically improving survival rates in severe trauma.
Wow. So Ringer provides the balance, Hartmann adds the buffer, and Shires demonstrates LR's critical role in trauma by understanding these fluid compartments. That really cemented LR's place, didn't it?
It became the cornerstone of trauma resuscitation for decades. But the fluid story, it keeps twisting.
Never straightforward, is it? What happened next?
Well, the 80s and 90s saw this rising tide of enthusiasm for something else, colloids.
Ah, right, the ones with the bigger molecules, like albumin.
Correct. Things like albumin, dextrins, starches. The theory was appealing. These large molecules should stay inside the blood vessels longer than the small salt molecules in crystalloids, like LR or saline.
Meaning you'd need less volume for the same effect, and it would last longer.
That was the idea. Less fluid needed, better blood pressure support, maybe fewer complications like swelling. For a while, there was a real feeling that maybe crystalloids were, a bit old-fashioned, that colloids were the future for serious resuscitation.
And it didn't quite pan out that way.
Well, the evidence was actually pretty mixed. Lots of small studies, often conflicting results. Then, in 1998, came a bombshell.
Which was?
A big meta-analysis from the Cochrane collaboration looking specifically at albumin, the most common colloid.
What did it find?
It was pretty shocking at the time. The analysis suggested that giving albumin might actually increase the risk of death in critically ill patients.
Increase, not decrease.
Exactly. Now, it's important to say this analysis was controversial. It was later criticized, maybe heavily influenced by some small, potentially biased trials. But the impact was immediate.
People got scared.
Oh, yeah. The sources we looked at mentioned reports of doctors in Europe basically dropping albumin almost overnight.
Wow. That shows the power of a big analysis, even a controversial one.
It absolutely does. And it really underscored the need for better, bigger, more definitive trials. And while a later, very large trial, the SAFE study in 2004 eventually showed albumin was generally safe compared to saline.
But not necessarily better overall.
Right. No clear survival benefit overall, though maybe some effects in specific subgroups. But the initial colloid hype definitely faded. The pendulum swung back towards crystalloids.
Okay, so colloids had their moment, but the focus returns to the crystalloids. And specifically, the old head-to-head lactated ringers versus normal saline.
Exactly. And a major driver for this renewed comparison was a growing unease about normal saline itself.
Even though it's called normal?
Ironically, yes. Its composition isn't actually that normal compared to human blood plasma. The big issue is chloride. Normal saline has a much higher concentration of chloride than our plasma does.
And if you give someone large volumes of it, that excess chloride, it causes problems.
It can. It can lead to something called hyperchloremic metabolic acidosis. Basically, the high chloride load makes the body's pH too acidic. And there was increasing concern that this wasn't just a lab finding, that it could actually be harmful, maybe damage the kidneys.
Okay, so suddenly normal saline doesn't look so benign. And lactated ringers, with its lower chloride and that lactate buffer,
Starts looking more physiologically balanced, potentially safer, especially when you're giving large amounts of fluid.
which sets the stage for the modern era, the big trials directly comparing them, the crystalloid wars, you called them.
Pretty much. And this is where things get really interesting with huge studies. Two pivotal ones came out of Vanderbilt University in the U.S. around 2018, the SMART trial and the SALT-ED trial.
Those were the big ones, right? Pragmatic trials.
Yeah, designed to reflect real-world practice. They used this clever design called cluster randomization. Instead of randomizing individual patients, they randomized entire hospital units like ICUs or emergency department areas to use either balanced fluids, primarily LR, or saline for set periods, then sometimes switching.
So comparing policies almost, what did they find?
It's pretty significant. The SMART trial involved over 15,000 critically ill patients in intensive care units. It found that using balanced crystalloids led to a lower rate of major adverse kidney events within 30 days, make 30.
Make 30. That includes things like death, needing dialysis, or having lasting kidney problems.
Exactly, a composite outcome. So a clear signal favoring balanced fluids for kidney health in the sickest patients. SMART also hinted, though it wasn't the main finding, that there might be a survival benefit for patients with sepsis who got balanced fluids.
Okay, that's the ICU. What about SALT-ED?
SALT-ED looked at over 13,000 non-critically ill patients admitted to the hospital through the emergency department, and it found a similar result. Fewer major adverse kidney events with balanced fluids compared to saline.
So evidence building up. Balanced fluids seem better for the kidneys, maybe across different types of patients. Seems like LR is pulling ahead.
It certainly looked that way.
Mm-hmm.
But, as always in science, it wasn't quite that simple, because other big trials followed.
Uh-oh, conflicting results.
Not exactly contradictory, but maybe less clear-cut. The BASICS trial, conducted mainly in Brazil with over 10,000 ICU patients, came out in 2021. And the PLUS trial from Australia and New Zealand, over 5,000 ICU patients, published in 2022. Both compared balanced solutions to saline in critical care.
And they found.
They didn't find a significant difference in their primary outcome, which was typically 90-day mortality. Overall survival.
Okay, wait. SMART SALT-ED show kidney benefits, maybe a sepsis survival hint. BASICS Plus show no overall survival difference in the ICU. How do you square that?
That's the puzzle researchers have been grappling with. It adds layers of complexity. Maybe the main benefit of balanced fluids is primarily renal protecting the kidneys, and that doesn't always translate into fewer deaths across the board in a mixed ICU population.
Or maybe the survival difference is real but small.
Possibly. Small enough that even these large trials might not have had enough statistical power to detect it reliably. BASICS also raised questions about how the fluids were used. Maybe consistency matters, starting balanced fluids early.
Yeah.
It just showed the picture was more nuanced.
So the takeaway was maybe balanced fluids are likely better for kidneys, especially if you need a lot of fluid or are very sick, like with sepsis, but maybe not a guaranteed lifesaver for every single patient needing an IV drip.
That's a fair summary of where things stood until today.
Right. The brand new study, the FLUID trial.
The FLUID trial out of Canada. And this one took yet another different approach. They went for a hospital-wide policy change.
Not just ICU or ED, but the whole hospital.
That was the idea. Another pragmatic, cluster randomized trial. But this time it was a crossover design. 7 hospitals participated. For periods, the hospital's default policy was to use lactated ringers for pretty much everyone needing maintenance or resuscitation fluids. Then they'd switch, and the default policy would be normal saline.
And they tracked outcomes for everyone.
Using administrative health data, yes. Over 43,000 patients admitted during the study periods. They wanted to see the real-world effect of making LR or NS the standard choice across the entire system.
Okay, the big question then. After Ringer, Hartmann, Shires, the colloid debate, SMART, SALT-ED, BASICS plus S, what did the FLUID trial find with this hospital-wide approach?
Their main outcome was a composite: death or hospital readmission within 90 days.
Yeah.
And the bottom line, no significant difference between the periods when LR was the default and when NS was the default.
No difference at all.
Statistically, no. The rate was about 20.3% with the LR policy versus 21.4% with the NS policy. That adjusted difference was tiny, minus 0.53 percentage points, and the confidence interval crossed 0, meaning it wasn't statistically significant. Other secondary outcomes look similar too.
Huh. Okay, for listeners who just heard about the kidney benefits in Smart and Salted, this might sound, well, a bit underwhelming. Does FLOED tell us it just doesn't matter which fluid you use for most people in the hospital?
That's the crucial question, and the answer is probably no. It doesn't mean it doesn't matter. We have to look really closely at FLOED's limitations. And the biggest one, it was seriously underpowered.
For meaning not enough patients.
Exactly. The trial got cut short because of the COVID-19 pandemic. They planned for 16 hospitals and around 144,000 patients, but they only managed to get 7 hospitals and about 43,000 patients enrolled.
So they didn't have enough data to reliably detect a small difference, even if it was there.
Precisely. They designed the study to detect what they considered a clinically meaningful difference for the health system, an absolute difference of just 1 percentage point in that primary outcome. The difference they actually observed was even smaller, around 0.5%. With the smaller sample size, they just didn't have the statistical power to say whether that tiny observed difference was real or just due to chance.
Were there other issues?
Well, adherence to the assigned fluid policy wasn't perfect, which can dilute any potential effect. And using administrative data is pragmatic, but maybe less precise than dedicated trial data collection for certain outcomes.
Did they see anything interesting in subgroups, like the earlier trials?
There was an interesting signal. They saw a trend suggesting LR might be better in patients over 80 years old. Again, you have to be super cautious interpreting subgroup analyses, especially in an underpowered study. Could easily be chance.
Okay, so let's try to put this whole modern picture together. Smart Salt Ed. Kidney benefits, particularly in sicker patients. Basics pluses. No clear overall survival difference in the ICU. FLOED looks hospital-wide, finds no difference in death admission, but it was underpowered.
It really paints a picture of nuance, doesn't it? It suggests that maybe the benefits of balanced fluids are most pronounced in specific situations. Maybe ICU patients, sepsis patients, those getting large volumes, maybe the elderly, and perhaps the benefit is strongest for kidney outcomes.
And maybe a hospital-wide policy for everyone just dilutes that effect too much to see it clearly, especially in an underpowered study.
That seems plausible. Or maybe the true difference is quite small overall. FLUED adds an important piece, showing that the context, who you study, what outcome you prioritize, how you implement the change, really matters.
So with all this complexity, where does that leave doctors today? What's the practical takeaway?
Well, if you look at the overall evidence, including meta-analyses that combine data from all these trials, the general trend in clinical guidelines is definitely shifting towards favoring balanced crystalloids like lactated ringers, especially for initial resuscitation, particularly in sepsis, and generally when patients need large volumes of fluid. The main driver is still the desire to avoid that hyperchloremic acidosis and potential kidney injury you can get with large amounts of saline.
But saline isn't gone completely. Are there times it's still the go-to?
Oh, for sure. Specific situations like managing severe traumatic brain injury often still favor normal saline based on different lines of evidence and concerns about brain swelling.
And what about those old fears about LR, like the potassium causing problems or the lactate making acidosis worse?
Those are largely proving unfounded in most patients. The amount of potassium is relatively small, and the lactate, as Hartmann showed, actually gets metabolized into buffer, usually helping acidosis rather than worsening it, unless the liver is severely failing.
So it really feels like we're moving beyond asking which fluid is number one.
Exactly. It's much more about the concept of fluid stewardship. Choosing the right fluid for the right patient, in the right amount, for the right reason. Tailoring the therapy.
And where does the research go from here? More big trials.
Possibly, but maybe more targeted ones. There's a lot of interest in precision medicine. Can we find biomarkers, maybe blood tests, that tell us which specific patient will benefit most from LR versus saline? Also, research into optimizing fluid composition even further. And crucially, implementation science.
Yeah.
How do we make sure best practices actually get used consistently everywhere?
It's just incredible, this whole arc. From a mistake with frog hearts in Victorian London.
Through battlefield trauma insights.
With these massive, complex, sometimes conflicting modern trials, this whole story feels like it has lessons way beyond just IV fluids.
I think so too. Ringer's accidental discovery, it's a classic case of the prepared mind, recognizing significance in an anomaly. You have to be looking closely.
And just the sheer time scale, over 140 years, from Ringer to FLUID. Science isn't usually instant breakthroughs. It's this long, incremental process, building, correcting, refining across generations.
Definitely. And Shire's work on the third space realizing the body isn't just simple pipes, but interconnected compartments. That's pure systems thinking, right?
Yeah.
Applies to ecology, economics, anything complex.
And that constant push and pull between what we've always done tradition and what the evidence suggests. The colloid debate, the LR versus saline saga, it shows how hard it can be to change practice, even with new data.
It takes real effort to question the normal.
Yeah, and maybe the biggest lesson is the paradox of simplicity. This bag of what looks like simple salt water holds such biological complexity, such profound effects, that it's fueled this century-plus scientific quest.
Sometimes the most basic things hide the deepest questions.
So wrapping up this deep dive, we've traced this journey from Ringer's lab to the latest FL Luby trial. It's a story of medical progress, absolutely, but also its challenges, its nuances, its ongoing nature.
We've learned a huge amount about fluid balance, the subtle impacts of different solutions, and just how critical context is, who the patient is, why they need fluid, how much they get.
And this new FLUA trial, while maybe not giving a simple final answer, adds this important perspective. What works in a targeted setting like the ICU might look different when applied as a broad policy across an entire hospital, especially if the overall effect size is small.
The search continues, refining our understanding.
And it leaves us, and you listening, with this final thought to mull over, drawing from this whole history. In a world often looking for easy answers, what seemingly normal everyday practice in your own field, your own life, might actually be less optimal than a slightly different, maybe even unbalanced alternative that perhaps no one's questioned closely enough. Something to think about.